UGC NET Electronic Science January 2025 question paper solutions part 1, that is from question number 51 to question number 75. First question: Thevenin's voltage is determined when all different options are given. Let us see Thevenin's theorem. So this Thevenin's theorem states that in a linear active bilateral network with one or more independent or dependent voltage sources or current sources are replaced by a single voltage source with equivalent series impedance or RTH. To calculate the value of Thevenin's resistance RTH, all independent sources are replaced by their internal resistances, that is, ideal voltage sources are open circuited and ideal current sources are short circuited. To calculate Thevenin's voltage, keep all the independent voltage and current sources active, or keep all sources as it is. Keep all the sources present in the network as it is. Do not disturb the active sources present in the network for calculating the Thevenin's voltage. So from the question, Thevenin's voltage VTH is determined when all the sources keep as it is. Correct option is 1, E only. So this Thevenin's theorem is not applicable for, note point is Thevenin's theorem not applicable for network having nonlinear elements not applicable for networks having nonlinear elements or unilateral element. Correct option is 1. Next question: Scaling principles. Statement A: Scaling principles are used to preserve original device characteristics in miniaturized geometry. Statement 1 is correct. Statement 2. Statement B: Miniaturization does not change the physical properties, hence device characteristics remain same. So miniaturization changes the physical properties, hence device characteristics remain same. Miniaturization affect the change in physical properties. Statement B is wrong. Miniaturization causes change in principal properties, therefore scaling is required. Statement C is correct. Generally, power supply voltages are not scaled, as IC have to be interfaced, which operate at standard voltages of 5 volts or so. Statement D is correct. Statement A, C, D are correct statements. Statement B is wrong. Therefore, correct option is 3. Next question: Determine VC, VB for the network given in the figure with beta is 45, current gain of the transistor is 45, and base emitter voltage is 0.7 volts. In the circuit given, the collector resistance is 1.2 kilo ohms and base resistance is 100 kilo ohms. This is the base voltage. Collector emitter terminal voltage applied is minus VEE and VCC voltage is 0. Collector terminal C. Given current gain of the transistor beta is 45, base emitter voltage VBE is 0.7 volts, base resistance RB is 100 kilo ohm, and VEE voltage applied to the emitter terminal is minus 9 volts. KVL at the input loop, KVL at input loop or input side, so that is VBE is equal to base voltage minus emitter voltage. So from this base voltage VB is VBE plus VE. VBE voltage is 0.7 volts, VE voltage is minus 9 volts. Therefore, base voltage VB is minus 8.3 volts. Now base current IB is base voltage minus 0. So this voltage with respect to ground, so that is 0. VB minus 0 by base resistance RB 100 kilo ohm. So its value is minus 8.3 by 100 kilo ohms. The base current is minus 83 micro ampere. So this minus indicates the direction of current. Now collector current IC is beta into IB. Beta value is 45. IB is 83 micro ampere. The collector current IC is 3.75 3.735 milliampere. Once collector current is obtained, then apply KVL at output side. So this is step 1, step 2, step 3 and step 4. KVL at output side, that is collector side. Collector voltage VC is equal to VCC minus IC RC. Here VCC voltage is 0, it is connected to ground. 0 minus IC 3.735 milliampere, and collector resistance given RC is 1.2 kilo ohm. 1.2 into 10 cube. Now the collector voltage VC is minus 4.482 volts. Therefore correct option is 1. Collector voltage is minus 4.48 volts and base voltage is minus 8.3 volts. Next question, it is related to thyristors. SCR is a silicon controlled rectifier which is an unidirectional device, meaning the current flows only in one direction. SCR consists of this silicon controlled rectifier. It is a 4-layer 3-junction 3-terminal 4-layer 3-junction 3-terminal unidirectional device. Silicon controlled rectifier is 4-layer 3-junction 3-terminal unidirectional device, whereas diac is 2 SCRs connected in anti-parallel. This is one SCR, second SCR, 2 SCRs connected in anti-parallel. It has two terminals, main terminal 1 and main terminal 2. This is a symbol for diac. Diac consists of 2 terminals. Next is triac. In this triac, triode AC switch, 2 SCRs are connected in anti-parallel with shared gate terminal. So triac consists of 3 terminals, main terminal 1, main terminal 2 and then gate terminal. IGBT, insulated gate bipolar transistor. Insulated gate bipolar transistor. It is a bipolar transistor with insulated gate terminal. The circuit symbol for IGBT is shown here. No. The question is diode. So option A, diode AC switch. It is a bidirectional diode thyristor. Diode is a bidirectional diode thyristor. Silicon control rectifier. SCR is unidirectional thyristor. Triac stands for triode AC switch, which is a bidirectional triode thyristor. So this diode consists of two terminals, whereas triac consists of three terminals. Both are bidirectional devices. Hence, triode two terminal is diode. Next, IGBT, insulated gate bipolar transistor. It is a bipolar mode MOSFET. Bipolar mode MOSFET. Correct option is A2, B4, C1, D3. A2, B4, C1, D3. Correct option is 4. Next question. This question is related to ion implantation and diffusion. So in this diffusion, atoms are placed atoms are placed on or near the surface of the wafer by deposition from gas phase of the dopant or by using doped gas sources. This is a curve for diffusion, and the curve for ion implantation is given here. Dopant ions are implanted into the semiconductor by means of ion beam. High velocity dopant ions for ion implantation. Gas of dopant atoms for diffusion. This from the given question. Of statement A, figure A and figure D corresponds to ion implantation. Figure A and figure D corresponds to ion implantation, whereas figure B and C corresponds to diffusion. Figure B and C, these two figures corresponds to diffusion. Figure A and D corresponds to ion implantation process. Correct option is 4. Next question. S1, S2, S3 are connected in cascade. Three systems are given. Three different systems are connected in cascade to form a new system S, as shown in the figure. Consider the statement. Statement A is if S1, S2, S3 are linear, then S is linear. Statement A is correct because linearity is preserved under cascaded connection. If S1, S2, S3 are causal, then system S is also causal. Statement C is correct. If S1, S2, S3 are time invariant, then cascaded system is also time invariant because this causality, time invariance property are preserved under cascade connection. Whereas the statement B, three systems are non-linear, then S is non-linear. It may be non-linear or may not be non-linear. Statement B is false. If all systems are linear, then total system is definitely linear. If all systems are non-linear, then total system not necessarily non-linear. So let us take an example for this. If suppose system S1 having a transfer function of 1 by root x, it is non-linear. For S2, again 1 by root x, non-linear. S3 is x square, non-linear. Here all the three systems are non-linear, consider non-linear individually. The cascaded system S1, S2, S3 is 1 by root x, 1 by root x into x square. So its value is x. So x is a linear system. Therefore, if if each individual component is non-linear, it is not guaranteed that overall system must be non-linear. It may be a specific configuration may result in linear behavior also. Therefore, statement B is incorrect. Correct option is A, C, D. 3. Statement A is correct. Statement C is correct. Statement D is correct. So correct option is 3. Next question. The output of 3-bit parallel counter is shown in the given figure with flip flop 1, flip flop 2, flip flop 3 waveforms. Here FF stands for flip flop. Here FF stands for flip flop. Different statements are given. When the clock pulse 5 is high, both FF2, FF3 are in its hold mode. So for this fifth clock pulse, FF2 and FF3, FF2 and FF3 are in hold mode. The statement is correct. So statement A is correct. On the trailing edge of sixth clock pulse, this is the trailing edge of sixth clock pulse, both FF1, FF3 toggle. So this statement is wrong. In the trailing edge of sixth clock pulse, FF1 is toggled, FF2 is in hold state, FF3 is in hold state, FF2 changes its states from 0 to 1. So here FF1, FF2 toggle, FF1 and FF2 toggle. FF3 is in hold state. FF3 is in hold state. So option B is incorrect. Next, when the clock pulse 5 is high, FF1 is toggle mode, FF3 is in hold mode. For the fifth clock pulse, FF1 toggle, FF2 hold state and FF3 toggles. Statement C is correct. Next, statement D, on the trailing edge of fourth clock pulse. This is the trailing edge of fourth clock pulse. All the three flip-flops changes its states, that is FF1 toggle, FF2 toggle and FF3 also is in toggle mode. It is not hold state. Therefore, statement A, statement C are correct. Correct option is 3. Statement B and D are incorrect. On the trailing edge of sixth clock pulse, FF1, FF2 toggle, FF3 is in hold state. On the trailing edge of fourth clock pulse, flip-flop 1, flip-flop 2 and flip-flop 3. All the flip-flops are in toggle state. Next question. Which of the following statements are correct for N-channel MOSFETs? So this is a symbol for N-channel MOSFET and symbol for P-channel MOSFETs are given. So in N-channel MOSFET, majority carriers are electrons, whereas for P-channel MOSFET, majority carriers are holes. The mobility of electrons is almost twice that of mobility of holes in the P-channel. So mobility of electrons is higher when compared to mobility of holes. Next is low input noise. N-channel MOSFET have low input noise and the transconductance of N-channel MOSFET is high. So let us see the statements. For N-channel MOSFET, holes are the current carriers. Statement 1 is wrong. The current carriers are, it is not holes, those are electrons. N-channel MOSFET has large transconductance than N-channel JFET has large transconductance than P-channel JFET. Statement B is correct. N-channel JFET has more noise than P-channel JFET. It is wrong. So N channel JFET has lower noise compared to P channel JFET. N channel JFET has higher mobility or large mobility than P channel JFET. Statement B and statement D are correct. Statement B, statement D are correct. Correct option is 3. Next question. For a PN junction diode, different statements are given. First statement is the condition of zero net electron hole currents requires that Fermi level must be constant throughout the sample. So statement A is correct. A constant Fermi level A constant Fermi level throughout the sample is required for zero net electron hole currents. This is because a constant Fermi level ensures that there is no net flow of charge carriers. Statement A is correct. The depletion layer width at thermal equilibrium at one side abrupt junction is independent of doping concentration. So statement B is incorrect because the depletion width is inversely proportional to doping concentration. It means the depletion width decreases as doping concentration increases. Next, 1 by C square versus V plot can yield doping density N, and extrapolation to 1 by C square is equal to 0 gives voltage built-in potential for one-sided abrupt junction. So statement C is correct. So statement C is correct. This is built-in potential. So built-in potential VBI for one-sided abrupt junction. So 1 by C square versus V plot can be used to determine the doping density and built-in voltage of the diode. The plot can also be extrapolated to 1 by C square is equal to 0 to determine the flat band potential. So statement C is correct. Statement D. For Xenon diode, if breakdown voltage VBD is larger than 6 electron volts, then breakdown mechanism is band to band tunneling and temperature coefficient is negative. So this is related to Zener effect. For Zener diode, temperature coefficient is negative and breakdown occurs for voltage less than 6 electron volts. So statement D is incorrect because it is not larger, it is lower than 6 electron volts. So correct statements are A and C. Therefore correct option is B. Next question. Static error coefficients Kp, Kb, Ka for a open loop transfer function is given below with unity feedback respectively will be. So given system. So open loop transfer function here unity feedback is given, therefore h of s feedback transfer function is 1. Positional error constant Kp is limit s tends to 0 g of s into h of s. Velocity error constant Kv is limit s tends to 0 s into g of s h of s. Acceleration error constant Ka limit s tends to 0 s square g of s into h of s. So calculate Kp. Kp is limit s tends to 0 g of s 50 by 1 plus 0.1 s plus 10 into h of s, its value is 1, that is 50 by 0.1 50 by 1 into 10. Kp value is 5. Kv is s into 5, that is 0. Ka is also 0. Here the type of the system is 0. For type 0 system, only positional error constant exists. This velocity error constant and acceleration error constant are 0. So correct option is B. Kp is 5, Kb is 0, Ka is 0. So let us see some conclusion points. For type 0 system, for type 0 system, positional error constant Kp is some constant value, velocity error constant is 0, acceleration error constant is 0. For type 1 system, Kp is infinity, Kb is some constant value, acceleration error constant is 0. For type 2 system, this positional error constant infinity, velocity error constant infinity, and acceleration error constant is some constant value. So for this question, correct option is 2. This type indicates number of poles at the origin. So type of system is number of poles at origin. Next question. In 8086 microprocessor, what are the machine control flags? Let us see the flag register of 8086 microprocessor. 8086 microprocessor consists of 16-bit flag register which is divided into two parts, machine control flags and condition code flags or status flags. Various status flags are sign flag, zero flag, auxiliary carry flag, parity flag, carry flag, overflow flag, and control flags are directional flag, interrupt flag, and trap flag. Directional flag, trap flag, interrupt flag. B, D, E. Correct option is 1. Machine control flags are B, D, E. This zero flag and sign flag are not machine control flags. Next question. For a desired sheet resistance RSH is 0.6 ohm per square and resistivity rho is 18 micro ohm centimeter thin silicate film. Calculate the thickness of the film. So thickness of the film. So we know that sheet resistance RS is equal to resistivity by thickness. Sheet resistivity is equal to resistivity by thickness. From this, thickness is equal to resistivity by sheet resistance. So resistivity is 18 into 10 power minus 6 ohm centimeter, that is 10 power minus 2 meters, and resistivity is 0.6. So on calculation, its value is 180 by 6, that is 30. 30 into 10 power minus 8, 30 into 10 power minus 8, that is 300 into 10 power minus 9. Sheet thickness is 300 nanometers. So correct option is B. And the square symbol refers to number of squares L by W length per width in a film, which is common notation in sheet resistance calculations. Symbol represents squares in length to width ratio, where L is length, W is the width of the rectangular sheet film. Correct statements are B, E. Correct option is 3. Next question. In 8086 microprocessor, what will be the physical address if the segment and offset address are given below? So the base address is a starting point of the program code and data, while a segment address defines the beginning of a memory segment. This physical address in 8086 is 20-bit address. Base address is starting address of segment. Offset address is displacement of the memory location from starting address of the segment. So this physical address 20-bit address is calculated by shifting the segment base address 4-bit left and then adding it to the offset address. Or otherwise, for the given data, to calculate the physical address, multiply the segment address with 10h at the offset address. So here segment address is 1005 multiplied with 10h, its value is 10050, and add the offset address is 5555. So hexadecimal addition, so 5510, its value is a 055055 155 a5. 155 a5 is a 20-bit physical address. Correct option is 2. Physical address is calculated by adding segment address to the offset address. Next question. What is the power radiated by Hertzian dipole? So we know that radiation resistance of Hertzian dipole is 80 pi square dl by lambda whole square. So radiation resistance for Hertzian dipole is 80 pi square L by lambda whole square, or differential length by lambda whole square, and the power radiated is IRMS square into radiation resistance. IRMS is I naught by root 2 whole square into radiation resistance, that is 40 I naught square pi square dl by lambda whole square. This is the power radiated by Hertzian dipole or Hertz dipole. 40 pi square I naught square dl by lambda whole square. Correct option is 1. Next, which of the following semiconductors in ascending order, increasing order of effective mass? So gallium arsenide, GAS, gallium arsenide, GAS, gallium arsenide, BN, boron nitride, INSB, indium antimonide, AS, aluminum arsenide, and GaP, gallium phosphide. So for these cases, the increasing order of effective masses is INSB 0.013, gallium arsenide 0.067, aluminum arsenide, boron nitride, and gallium phosphide. So for gallium phosphide, it is highest. Correct option is CADBE. Option 4 is correct. Next question. Arrange the power amplifiers according to the angle of conduction. For class A power amplifier, conduction angle is 360 degrees. For class B power amplifier, conduction angle is 180 degrees. For class C power amplifier, conduction angle is less than 180. For class AB, it is in between 180 to 360 degrees. The correct option is 3. decreasing order. So highest is for class A, in the decreasing order. So correct option is highest is for class A, that is B, followed by class AB, and then class B, and finally class C less than 180 degrees. This is the decreasing order of conduction angle for different power amplifiers. Next question. Arrange the following interrupts of 8086 microprocessor in decreasing order of priority. So in the interrupts of 8086 microprocessor are divided into two basic categories. One is hardware interrupt and software interrupt. Hardware interrupts are of maskable interrupts and non-maskable interrupts. So reset, which is having highest priority. Reset is having highest priority. Next, non-maskable interrupt, hardware interrupt, internal interrupts, and then finally software interrupts is having lowest priority. But as per the question, none of the option is correct. Priority order of interrupts. Reset is having highest priority and software interrupts have lowest priority. Next question. ECG statement A is EEG, electroencephalogram. It is used to measure the electrical activity of brain. So A is 2. ECG, electrocardiogram, measures the electrical activity of heart over the period of time. So ECG is, it measures the heart activity. Next, EMG, electromyography, diagnostic procedure used to assess the health of muscles and nerve cells that control the muscles and nerve cells. It records the electrical activity produced by skeletal muscles, nerve and muscular activity. So that is EMG, nerve and muscular activity, electromyography. Next, electrokilography, EOG. It is a technique for measuring the electrical potential between front and back of the human eye. So that is activity between cornea and back of the eye. A2, B1, C4, A2, B1, C4, D3. Correct option is 3. Next question. An LTI causal system is described by the differential equation initially at rest. So that is initial conditions are 0. Initial conditions are 0. This differential equation can be represented as apply Laplace transform. Laplace transform for this differential equation is Laplace transform on both sides. Laplace transform of d square y by dt square s square y of s, Laplace transform of dy by dt s into y of s, Laplace transform of y of t is y of s, capital Y of s, Laplace transform of x of t is capital X of s. The transfer function of given differential equation is Laplace transform of y of s by Laplace transform of x of s is 1 by s square plus 3s plus 2. 1 by s square plus 3s plus 2, that is h of s, transfer function. h of s, that is transfer function y of s by x of s is 1 by s square plus 3s plus 2. Next, what will be the output y of t for the step input signal? Now, for input x of t, Laplace transform of input signal x of t, that is step signal u of t, it is 1 by s. X of s is 1 by s. Now y of s is x of s by s square plus 3s plus 2 into x of s, that is 1 into x of s. So replace x of s as 1 by s. So 1 by s into h of s, 1 by s square plus 3s plus 2. So rearrange the expression, 1 by 2s plus minus 1 by s plus 1 plus 1 by 2, 1 by s plus 2. This is y of s for the input x of s. For the step input y of s, apply inverse Laplace transform. Inverse Laplace transform of y of s, that is y of t is equal to 1 by 2 u of t minus 1 e power minus st u of t plus 1 by 2 e power minus 2t. Here it is e power minus 1t. E power minus 1t is e power minus t. Therefore, correct option is 2. H of s is 1 by s square plus 3s plus 2. Y of s is 1 by 2 minus e power minus t plus 1 by 2 e power minus 2t into u of t. Correct option is 2. Next question. Triacs have low dV by dt rating compared to silicon controlled rectifiers. That is the statement A. Let us see. Triacs are generally less robust to rapid change in voltages dV by dt compared to silicon controlled rectifier. This makes them more prone to false triggering noisy environment. Statement A is correct. So statement A is correct. Triacs have more low dV by dt rating compared to silicon controlled rectifier. Statement B, reliability of triacs is more than silicon controlled rectifier. So statement B is wrong. Reliability of triode AC switch is less than silicon controlled rectifier. SCRs are silicon controlled rectifiers are more reliable and robust, especially in high power applications. Triacs are more sensitive and less rugged. Next, triacs can be triggered with both positive and negative gate signals. Triac can conduct in both directions and are bidirectional devices. Statement C, triacs can be triggered with positive polarity voltage only. Statement C is wrong because triacs can be triggered with either with positive voltage or with negative voltage. Triacs needs single heatsink while silicon control rectifier requires two heatsinks. Statement D is correct. Statement A, statement D are correct. Correct option is 3. Next question. Arrange the following in the order of decreasing transmission power requirement. So conventional AM or double sideband full carrier amplitude modulation. It has carrier frequency, upper sideband and lower sideband. It consists of carrier frequency, upper sideband and lower sideband, whereas DSB SC double sideband suppressed carrier, it consists of upper sideband and lower sideband. Next, VSB SC vestigial sideband suppressed carrier modulation, it consists of lower sideband LSB plus a vestige of upper sideband, or otherwise it consists of upper sideband plus vestige of lower sideband. Next is SSB SC. It consists of either lower sideband or upper sideband. So this is the power requirement in amplitude modulation. So power requirement in frequency modulation. The power requirement in frequency modulation is less than power requirement in amplitude modulation. FM require least power. So decreasing order of transmission. So FM require least power and highest power is for AM, conventional AM, followed by double sideband suppressed carrier. So that is BCDEA. Correct option is 1. So first is AM, highest power, AM, lowest power is for FM, highest power is for AM, B, followed by DSB, SE, double sideband suppressed carrier, then vestigial sideband, followed by single sideband, and then frequency modulation. So power requirement is highest in amplitude modulation, lowest in frequency modulation. So this is the priority order. DSBSC, vestigial sideband, single sideband suppressed carrier, and then finally frequency modulation. Correct option is 1. Next question. The port 3 of 8051 microcontroller. Port 3 of 8051 microcontroller. So the port 3 of 8051 microcontroller is 8-bit bidirectional IO port. Each pin of port 3, that is from 3.0 to 3.7, can be used either as general purpose IO or special functions. These port 3 pins are bit addressable. Port 3.0 is RDX, serial input. 3.1 is TDX, serial output, transmits data for serial communication. 3.2 INTO, external interrupt 0. 3.3 external interrupt 1. 3.4 timer 0 input. 3.5 timer 1 input. 3.6 write control. 3.7 read control. 3.0 is serial input. 3.3 external interrupt. 3.6 write control. 3.7 read control. 3.0 A serial data input RxD. 3.3 it is 1 external interrupt. 3.6 write bar. 3.7 read bar. Correct option is A3, B1, C4, D2. Correct option is 2. A3, B1, C4, D2. Next question. Monostable multivibrator. It acts like a delay element. Monostable multivibrator consists of one stable state and one quasi-stable state. It is used for the generation of single pulse of specific duration. So functionally, this monostable multivibrator acts like a delay element. Bistable multivibrator, it is nothing but a flip-flop which can store one bit of information, either 0 or 1. When multiple flip-flops are connected in series or connected in cascade, it acts like a counter. Clamping circuit, it is nothing but DC translator, DC level shifter. Smith trigger, it is nothing but a comparator that uses positive feedback. Comparator with positive feedback. Smith trigger is a comparator. Clamping circuit, DC level translator. Bistable multivibrator, it is a counter. Monostable multivibrator, it is a delay. Therefore correct option is A3, B1, C4 D2. Correct option is 2. A3 B4 C2 D1. Next question. Probability of error for BPSK modulation scheme. For BPSK modulation scheme, the probability of error is 1 by 2 error function of square root of EB by N naught. So here the bit energy in BPSK modulation scheme, bit energy is same as symbol energy 1 by 2 error function of square root of ES by N naught. So correct option is 4. Similarly, for coherent FSK, binary FSK, probability of error is 1 by 2 error function of square root of EB by N naught. For non-coherent FSK, probability of error is 1 by 2 exponential of minus EB by 2 N naught. For differential PSK, 1 by 2 exponential of minus EB by N naught. For M array quadrature amplitude modulation, probability of error is 4 into 1 minus 1 by root m q function of under root 3 EB by m minus 1 into n naught. For M array PSK, probability of error is given. Therefore, as per this question, probability of error for BPSK modulation scheme is 1 by 2 error function square root of ES by n naught or EB by n naught. Next question. Jump shot label. It is an intra-segment direct mode. Jump shot label is an intra-segment direct mode. Jump 5000 H, 2000 H, inter-segment direct mode. Jump 2000 H address, inter-segment indirect mode. And this statement 4 is intra-segment indirect mode. So in the given question, inter-segment indirect mode. So correct option is 3. So let us see this. For a control transfer instruction, the addressing mode depends on destination location, whether it is within the same segment or within the other segment or different segment. So based on that, the control transfer instructions are inter-segment addressing modes, intra-segment addressing modes. In inter-segment addressing modes, if the location to which control is to be transferred lies in the different segment other than the current one, then it is inter-segment. If the destination location lies within the same segment, then it is called intra-segment. So addressing modes are inter-segment, intra-segment. In inter-segment direct and inter-segment indirect. In intra-segment direct, intra-segment indirect. 4 different classifications are given. This jump 5000 H, 2000 H, jump to effective address 2000 H in segment 5000 H. It is an inter-segment direct, inter-segment indirect. Jump 2000 H, jump to an address into the other segment specified at effective address 2000 H in DS data segment register. Next, intra-segment direct mode, jump short label, intra-segment indirect mode, jump effective address stored in BX, jump BX, effective address stored in BX. Here the correct option is 3. With this part 1 solution.